Hey everyone, welcome to the video. This is a class project for Numerical Methods 2 with Dr. Perez's Spring 2019. In this video, we will go over how to use the MATLAB program to find groundwater flow with boundary conditions. I will show you how to run the program and the needed conditions that are need to be known. Thank you. For the program to run successfully, you will need the Gaicedo code, the program code, and the figure code that are all presented in the file. Along in this file, you're going to want to have your boundary conditions and the constant values as .txt files. They should all be in the same folder for easy access when running the program. The boundary conditions should be set as -1 for a constant flow boundary, 1 for a no flow boundary, and 2 at the node that contains a well or pump, and 0 for all other active nodes. If you have a well or pump, please input the flow rate in the corresponding node in your constant file. I'll go ahead and click on the constant file and boundary file to show you something that we have that is similar. So now I will go ahead and show you our example for the conditions and elevation values. By clicking on boundary conditions, you can see that on the top row we have the -1, which state the constant boundary. The 1 here on the sides and below indicate the no flow, 2 for the pump, and 0 for all our active nodes. By clicking on the elevation values, we have our known constants for the elevation, as well as the GPM or flow rate for the pump at the corresponding node that was indicated in the boundary file. So we will now begin to run the MATLAB program. By doing so, all you have to do is simply click on the AP Test MATLAB code file. By double clicking on that, it should take you to the MATLAB file. And then to run the program, you can simply click on the Run button up in the top left-hand corner. By clicking Run, it will open the terms and conditions. This just lets you, the user, know that this program is for a region that is assumed to have isotropic and homogeneous soil conditions. It is also assumed that the distance between each node in both x and y direction are the same. Okay. Now, once terms and conditions are accepted, you can click OK. You will be taken to the GUI, where you'll be able to enter all of your known, enter your boundary conditions file, constant values file, or elevation file, and or elevation file, along with your hydraulic constant, distance between elevations, and you will be able to run the find groundwater flow once everything is entered. So now the program was run successfully, and MATLAB was able to generate a velocity profile as well as a groundwater profile for you, the user, to use. We also added some tools that will help the user understand more of the groundwater flow. By clicking on the graph, you can click on the rotation button that will allow you to rotate the graph and see the flows in 3D. And by clicking onto the color bar, it also shows you the elevations of the corresponding flows. So here 150 is your highest point, minus 350, and as I said earlier, the rotation lets you know where the pump is drawing water from and the direction of the water, and it corresponds to the velocity profile listed above. Also, once you accept the graphs, you can also save their elevation file by simply entering a name here. Example EV, save your velocity file, XD, and example Y direction YD. By clicking on these push buttons, it will save the files for you into your folder. For example, save. As you can see here we have our value. You can go ahead and click on this and gives you all the values you need to the corresponding graphs. And that is our program for the groundwater flow in the Milk Methods 2 Dr. Menez's Spring 2019 class. Thank you very much. Have a nice day. Bye.